Pluto has long been a world of mystery, a frozen, forgotten outpost lingering on the farthest edge of our solar system, where sunlight barely reaches. When NASA's New Horizons spacecraft flew by it in 2015, humanity saw the surface of Pluto for the very first time. But what was anticipated as a barren rock proved wonderfully dynamic, complete with glaciers and towering ice mountains, and a delicate, shimmering atmosphere. Yet hidden in that stunning data was a mystery that NASA never fully solved. Pluto's atmosphere was many times colder than scientific models predicted. While calculations had temperatures pegged at around -73 degrees Celsius, actual readings disclosed levels more than 30 degrees colder. That was not an inconsequential discrepancy, it was a cosmic anomaly. Something, or perhaps someone, was cooling Pluto in ways no known physical mechanism could explain. For almost a decade, the mystery lingered once and for all, until now. The James Webb Space Telescope, humanity's most powerful observational tool, has finally exposed what is really happening on Pluto. And the answer is far more shocking than anyone could have imagined. When New Horizons sent back its breathtaking imagery, scientists anticipated a desolate landscape. Instead, they discovered vast nitrogen plains stretching for hundreds of kilometers and mountains made of solid water ice. Above this alien terrain floated a thin bluish haze, encircling Pluto like a delicate veil. This haze extended almost 300 kilometers high, far beyond what was thought possible for a body so small. It shimmered under faint sunlight, forming luminous bands in the upper atmosphere. Yet, beneath its beauty lay the real puzzle: the temperature. Pluto's atmosphere was freezing beyond any explanation involving methane or nitrogen. For years, scientists recalibrated instruments, reran climate models, and scrutinized every byte of data, but the math never aligned. The planet was losing heat faster than theory allowed. Something invisible was siphoning energy from Pluto's skies. Then, in 2017, Shi Zhang, a planetary scientist from the University of California, Santa Cruz, floated an idea that sounded extreme, even ridiculous, at the time. Pluto's haze wasn't passive dust and ice, it might be active, chemically alive in a sense, regulating the planet's temperature. He said that tiny particles high in Pluto's atmosphere could absorb ultraviolet light from the distant sun and re-emit it as mid-infrared radiation, effectively releasing heat into space. This process wouldn't warm Pluto, it would cool it. The haze, Zhang said, functioned as a colossal thermal shield. Most of the scientific community dismissed the idea. After all, the notion that particles dominated atmospheric temperature ran counter to established planetary physics. But Zhang made a bold prediction: if his hypothesis were true, Pluto's haze would emit a unique mid-infrared glow detectable by only one instrument, the James Webb Space Telescope's mid-infrared instrument, or MIRI. In May 2023, that test came. An international team led by Tanguy Bertrand used Webb to observe Pluto and its moon Charon. For the first time, Webb's precision allowed them to isolate Pluto's faint thermal signals from those of its moon. Using MIRI, they scanned the dwarf planet across wavelengths of 15, 18, 21, and 25 microns. The data was startling. Pluto's infrared glow was stronger than expected, far beyond what its frozen surface could emit. When the researchers subtracted Charon's contribution, they discovered that the excess heat originated not from Pluto's crust but from its atmosphere. The emission patterns matched Zhang's prediction exactly. The haze was glowing in the mid-infrared, radiating heat into space. NASA had finally located the missing energy. The haze wasn't a byproduct, it was the cause. This single discovery upended decades of assumptions. Scientists had long believed that atmospheric gases dictated planetary climates: carbon dioxide on Venus, methane on Titan. But Pluto shattered that rule. Here, solid particles, complex, tar-like molecules known as tholins, controlled everything. These tholins form when ultraviolet radiation strikes methane, creating intricate hydrocarbon chains. As they descend, they layer into a haze that glows in infrared, cooling the atmosphere from above. Pluto, it turns out, operates like a chemical engine. Haze forms, radiates, collapses, and reforms in rhythmic cycles with each orbit. Even more fascinating, Webb's data revealed that methane escaping from Pluto's upper atmosphere drifts toward Charon. There, sunlight transforms it into reddish organic compounds, literally painting the moon's poles. But the revelations didn't end there. The findings hinted that Pluto's bizarre cooling process might not be unique. Webb's team turned their gaze toward Titan, Saturn's largest moon, whose orange haze and methane-rich air had long intrigued scientists. To their astonishment, Titan displayed almost identical mid-infrared emissions. It was radiating energy away in the same way Pluto did, as though its atmosphere were breathing heat into the void. The similarities were uncanny, earning Pluto and Titan the nickname mirror worlds. Even Neptune's moon Triton began showing subtle traces of the same pattern, implying it may have its nitrogen haze behave under the same physical law. Suddenly, a new idea emerged: the outer solar system wasn't silent or frozen. These distant icy worlds were active, communicating through the language of chemistry and light. Webb's instruments soon revealed the deeper secret of the compounds driving this cosmic cooling. It turned out that tholins were far more complex than anyone had realized, containing hydrocarbon chains with nitrogen and oxygen, the same foundational elements of amino acids. On Earth, these reactions happen in our upper atmosphere when sunlight interacts with methane, the exact process that may have triggered life's first spark billions of years ago. Pluto's haze was not just cooling, it was actually cooking chemistry. Dr. Bertrand termed this prebiotic photochemistry on a planetary scale. There was, however, something deeply strange about this process. Webb's data showed rhythmic emissions synchronized with Pluto's 6.4-day rotation, which suggested the haze wasn't random. It seemed to respond to daylight cycles pulsing in harmony with the planet's rhythm, as though somehow attuned to sunlight itself. The boundary between chemistry, physics, and something beyond began to blur. Comparisons extended beyond our solar system. When astronomers examined exoplanets orbiting dim red dwarfs, such as K2-18b and TOI 700d, Webb detected faint infrared dips mirroring Pluto's spectral patterns. It was shocking. These were massive, warm worlds, yet their atmospheres behaved like Pluto's, glowing faintly, radiating excess energy, and maintaining surprising stability. That stability could imply habitability. Perhaps life doesn't need oceans or warmth. Perhaps it can thrive in chemical equilibrium, sustained within protective hazes that moderate temperature and filter radiation. For the first time, scientists considered that Pluto might not be an oddity, but a model, the first example of a type of world capable of sustaining prebiotic chemistry in deep cold. When Webb's findings reached NASA, several internal reports were quietly pulled from public databases. One, titled Atmospheric Anomalies, Pluto and Triton Comparative Study, mentioned non-thermal infrared emissions inconsistent with equilibrium models. Translation: Pluto was breaking the laws of planetary energy balance. The haze seemed to absorb energy from an unidentified source. Further analysis found weak electromagnetic pulses above Pluto's terminator line, the boundary dividing day and night, flickering in a precise, repeating rhythm. Some believed it to be auroral activity, others suspected electrical discharge. But one detail stood out: haze particles exhibit properties consistent with conductive microstructures. Conductive, meaning capable of carrying current. If true, Pluto's atmosphere might act like a planetary circuit, distributing electrical energy across its skies. Suddenly, the question changed. It was no longer why Pluto was cold, but what it was doing with all the energy it released. Then came the final revelation, one that changed everything. When Webb turned its instruments toward Pluto's night side, scientists expected nothing but darkness. Instead, they found light. Faint, rhythmic, structured light pulsing across wavelengths that no natural process could produce. Initially, it was blamed on Charon's reflection, but the geometry didn't fit. The pulses were too precise, repeating every 247 seconds, the same mysterious frequency detected months earlier in deep space. The realization was immediate and chilling: the same cosmic signal observed billions of light-years away was now emanating from Pluto itself. NASA's spectral analysis confirmed that each pulse encoded variations in amplitude-forming ratios of 1.618, 3.14, and 2.718, the golden ratio, pi, and Euler's number constants that define the structure of the universe. This was not random energy. It was organized. It was intelligence. The emission was swiftly classified and dismissed publicly as instrumental interference, but a handful of independent researchers had already downloaded the raw data. Their reanalysis revealed the pulses weren't coming from the atmosphere at all but from beneath Pluto's surface. Webb spectrometer traced the echoes to a reflective layer about 12 kilometers deep, not rock or ice, but metal. A vast, perfectly spherical metallic structure spanning nearly a third of Pluto's diameter. For decades, scientists thought Pluto was geologically dead. Now, tremors and electromagnetic pulses suggested motion beneath the crust, deliberate, rhythmic, mathematical. One scientist described it in disbelief: "It's like the planet is trying to speak." NASA quietly classified the finding, redacted the data, and demanded non-disclosure agreements from involved personnel. Yet one anonymous note later leaked, containing just 7 haunting words: "Pluto is not what we thought it was. It's something built." The weak pulse remains to this day, occasionally growing dim, occasionally brightening, as if in response to being observed. Every cycle encodes the same constants, the same universal mathematics, written into the silence between the stars. The question confronting humanity is no longer what Pluto is, but who put it there. So if this story has made you wonder what NASA really knows about the outer solar system, don't look away. Subscribe, because the next time the James Webb Telescope gazes at Pluto's frozen heart, the universe itself may just answer.